hopefully everybody can hear me. Otherwise, I put this sign up for people who can't hear anything, so they know that they need to get the sound going. Okay, so this is the lesson for section 2.6. That's chapter 2, section, or 7, I mean, chapter 2, section 7. This is a lesson out of the geometry study guide for chapter 2. So, this lesson is on using linear pairs and vertical angles. Now, previously, we talked about the definition of those two concepts. Back in, if I can find it here, linear pairs and vertical angles, it might have been in chapter 1. Let's see. Yep, okay. So linear pairs and vertical angles were two concepts that we learned back in chapter 1. A linear pair is two angles that are supplementary and next to each other. So, for example, if I had these two angles, angle number 1 and angle number 2, you can see they add up to 180 degrees because they form half a circle. They start on one side of a straight line and they rotate all the way over to the other side of the straight line when you combine them together. So they add up to 180 degrees and they are next to each other. The word for next to each other is adjacent. Okay. Vertical angles is the other concept. Vertical angles are two angles that are across from each other on an intersection. So on any intersection you actually have two pairs of these. This is one pair of vertical angles, and then this is the other pair of vertical angles. They are on opposite corners of an intersection of two lines. So the other thing that you need to know about vertical angles is that they are congruent. This pair, for example, if this one is 100 degrees, let's go with 110 degrees, then this one is also 110 degrees. And if this one is 70 degrees, then this one is also 70 degrees. Vertical angle pairs are congruent to each other. The right angle congruence theorem simply says that if you have right angles, they are also congruent. One right angle, the other right angle, yep, they are going to be the same measure as each other. So that means they are congruent. They are the same. So far in this chapter we've been working on proofs. This is an example, yet another example of a proof. So in this proof they want us to prove that angle K and angle L are congruent. Well, we can't just go ahead and say that they are. What we need to do is work from the given information. So we state our given information. Almost always it is stated on the first line. Sometimes it's broken up and part of it's stated in the first line and then part of it is stated on a line elsewhere in the proof. But I like to state it all in the first line. Reason, it was given. We can assume that it is true. So if we know that JK is perpendicular to KL, don't we know that angle K is a right angle? Sure. And if ML is perpendicular to KL, don't we know that angle L is a right angle? We know that because that's what perpendicular means. So, whenever something is kind of obvious, it's because it's very clear from the other thing that was stated. Hey, perpendicular lines form right angles. So because of the definition of perpendicular lines, we can state that angle K and angle L are congruent. They are right angles. And then finally, the last line here, we only have 3 lines, so this must be our final line. We state our statement that we've been asked to prove, that angle K and angle L are congruent. We know that because of this theorem here, that all right angles are congruent to each other. So I will simply cite the right angle congruence theorem as my reason. And that's it. So if two angles are supplementary to the same angle, they are congruent. Oops. C-O-N-G-R-U-N-T. There we go. Okay, so what that means is angle 3 and angle 2 are supplementary. That means they add up to 180 degrees. And angle 1 and angle 2 are also supplementary. They add up to 180 degrees. So if 3 is supplementary with angle 2 and 1 is supplementary with angle 2, what they're saying is that angles 1 and 3 would have to be supplementary, or have to be congruent, is what I'm trying to say. And if you think about it with actual numbers, it makes sense. Let's say angle 2 is 150 degrees. That means that if these two together add up to 180, this would have to be 30 degrees. And again, if angle 2 is 50 degrees and these two add up to 180, then this would also have to be 30 degrees. So that's really all they're saying is if two angles are supplementary with the same angle, then they have to be congruent with each other. Theorem 2.5 says if two angles are complementary to the same angle, they are congruent. So it's kind of the same idea. Congruent. So if these two together form a 90-degree angle, and these two together form a 90-degree angle, then 5 and 6 are called complementary angles. They add up to 90. And angles 4 and 5 are adding up to 90, so they're also complementary. So let's say the central angle, this middle angle here, is 50 degrees. If these two add up to 90, this one has to be 40. And if these two add up to 90, this one would have to be 40. So that's all they're saying, is that if you have two angles that are complementary with the same other angle, that they'd have to be congruent. You can see 40 degrees and 40 degrees is the same thing. That means congruent, same measure. So we can state that angle 4 and angle 6 are congruent. All right, on the next page we have the linear pair postulate and the vertical angle congruence theorem. So we talked about linear pairs and vertical angles on the first page. Linear pair postulate says if two angles form a linear pair, then they are supplementary. It's one of the definitions of a linear pair. They are two angles that add up to 180 degrees. You can see that half a circle right there. That's 180 degrees. Supplementary. And the vertical angles congruence theorem simply says that if you have a pair of vertical angles, for example, this one and this one, they have to be congruent with each other. It's kind of just the definition of a linear pair and the definition of vertical angles. The only thing is that this is missing the fact that it's not stated explicitly that they have to be adjacent, but when you read the word linear pair, that's implied. They have to be next to each other. Okay, example 3 is a proof, and we're going to use this concept that angles across from each other have to be congruent, they have to be the same measure. So, in this diagram, really all they told us is that angle 4 is a 90-degree angle, but really they stated it in words. They said that angle 4 is a right angle. So, since that's all we have to start with, I'll write that in my first line of my statement side of my... Sorry, my handwriting is a little atrocious today. See if I can space that out. I was trying to smush it together. Okay. Perhaps that's a little bit more legible. And the reason is it was given information. We can assume that that's true. Okay. Well, what are we trying to do here? We are trying to show that angle 2 and angle 4 are supplementary. That means that they add up to 180. Well, if I could show that angle 2 and angle 4 are each 90 degrees, then I could state that they're supplementary because 90 plus 90 is 180. So let's see. Because angle 4 is a right angle, then I know the measure of that equals 90 degrees because it's a right angle. Remember, when it's just obvious what the reason is, if it's directly from the statement above, you can say it's because the definition of a right angle says so. Okay. Number 3. What I would do is I'm trying to make a connection between angle 2 and angle 4. That's these two. And what I do see is that they are vertical angles. So I'm going to go ahead and say that the measure of angle 2 is equal to the measure of angle 4 because of the vertical angle congruence theorem. Okay, now I have a distinct connection between angles 2 and 4, which are part of my proof. I want to state that they're supplementary. Right now I have a statement of equality, but let's see. If the measure of angle 2 equals the measure of angle 4, and the measure of angle 4 equals 90 degrees, what I could say is the measure of angle 2 must also equal 90 degrees. And that I'm going to state simply because of substitution, that I'm going to state this statement again, but instead of calling this the measure of angle 4, I'm going to call it 90 degrees, because angle 4 is 90 degrees. That's the substitution property. Okay, so at this point I know that measure of angle 2 equals 90 degrees and the measure of angle 4 equals 90 degrees. So I know that because 90 plus 90 equals 180, that they must be supplementary. So because it's just simply stating something that's true, 90 plus 90 is 180, meaning that we know that therefore they are supplementary angles. It comes from the definition of supplementary angles. And there you go. There is my proof. Alright, so find measure of angle 1 and angle 2 if measure of angle 4 is 63 degrees. Well, angle 4 would be the same as angle 2 because they're vertical angles. They're across from each other. They're on opposite corners of an intersection of two lines. So I'm going to say that the measure of angle 2 is 63 degrees. What's the measure of angle 1? Well, it seems to me that angles 1 and 4 form half a circle because they start on one side of a straight line and rotate around over the other when you put them together. So half a circle is 180 degrees. So if angle 4 is 63, in order to find angle 1, I would simply take 180 degrees, subtract 63 degrees, and I would get 117. So more formally stated, the measure of angle 1 would be 117 degrees. Now, try not to be confused by this, but we are going to now move on to a different question. This question uses the same diagram, but it doesn't mean that these numbers can carry over to this one. Once we started a new question, you can't always assume that these numbers are going to transfer here. So if there's ever any question about whether you can use these numbers to answer the next question or not, just ask your teacher, especially on a quiz, because that's not the type of question that's bad. We can clarify what they're asking you to do and how the diagram is appropriately used to answer the question. So be a good self-advocate and get that question answered if it arises. Okay, so this is the type of setup where now we're going to just ignore these numbers and we're just going to start fresh with this diagram with new numbers. So for example, measure of angle 3 is 121 degrees, and they want to know all three of the other measures. Well, because 1 and 3 are vertical angles, they're kitty corner across from each other on an intersection of two lines, they must be the same amount. So angle 1 is going to be the same amount as angle 3, 121 degrees. Now, angle 4 is supplementary with angle 3. They start on one side of a straight line and they rotate over to the other side of a straight line. That's half a circle. So angle 3 and angle 4 must add up to a total of 180. So since angle 3 is 121 degrees, I can find angle 4 by simply saying, okay, if I subtract 121 from 180, I get 59. So that must be the measure of angle 4. And then lastly, angle 2. Angle 2 is directly across from angle 4. That means, on this intersection, that means that they're a vertical pair and they must be congruent. So I'm just going to steal my answer from there for angle 4. Measure of angle 2 must be the same. Now we can use these same ideas with a little bit more algebra. And you're going to see the algebra crop up more in the B-level questions. So let's take a look at number 11 and number 14. Okay. Now we're going to be a little bit cramped for space, so try to draw or try to write efficiently when you use your space. Okay, so here's what I see. I see something very similar to what we just did at the bottom of the previous page. I see this angle right here being directly across from this angle right here. Do you see that on this intersection of two lines? And that means that they're a vertical pair, and that also means they must be congruent. So whatever this angle's measure is, which we don't quite know yet, it must be the same as this angle's measure. So when two things are the same in math, we can say they are equal. I can make a true statement that 15x minus 1 must be equal to 13x plus 9. So with this equation, we can solve for x and find our first answer. I'm going to subtract 13x on both sides, leaving me 2x minus 1 here and 9 here. Then I'm going to add 1 on both sides, giving me 2x equals 10. And then I'll divide both sides by 2. And I now figured out that x equals 5. The other two angles are also a vertical pair. This one right here is congruent with that one right here because they're a vertical pair. You can see that each one of them includes a y. So when we construct an equation, it shouldn't be too hard. To solve it, because we'll only have one variable. So I'm going to say that this angle and this angle are the same. So in math we say that they are equal. And then because we have one big equation and only one type of letter involved, one variable, this can be solved for that letter. y. Over here, we're going to use what's called the distributive property. We'll multiply here and here with our 2, giving us 6y minus 50 equals 4x plus 2. And I'm going to subtract 4y on both sides, leaving me with 2y minus 50 equals 2. Add on both sides by 50, so I get 2y equals 52. And then I'm going to divide both sides by 2, leaving me with y equals 26. Now really we're going to do the same basic thing over here. We're going to recognize that this angle and this angle are a vertical pair, so they must be congruent. In other words, we can then say that they are equal. And this angle here and this angle here are a vertical pair, and that must mean they are congruent as well. So we can state that this angle, 16y minus 27, must be equal to the other angle, 13y. So all I have to do now to find x and y, that's the directions, is do some equation solving. And I will find my answers for both x and y. Okay, this proof is our last example for section 2.7. Alright, so they're going to start by telling us that angle 2 is congruent to angle 3. That's all given information that they've provided us with. And that forms the basis for our first line of our 2-column proof. Now, is there anything else that I know? Well, I know that angles 1 and 2 must be congruent because they are a vertical pair. Angle 1 is congruent to angle 2. And I also know that angles 3 and 4 are congruent because they are a vertical pair. Angle 3 is congruent to angle 4. So when I said because they're a vertical pair, that's the reason. The reason is the vertical angle congruence theorem. Okay. Now, let's see here. What we want to eventually do is say that angle 1 is congruent to angle 4. Can I say that? Well, it seems to me that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, so couldn't I say that angle 1 is congruent to angle 3? Yes. Now, what is that called? What's the property that I could name that with? If 1 is congruent to 2 and 2 is congruent to 3, then angle 1 is congruent to 3? Well, that is back here in the packet. That's the transitive property. So that's what I'm going to write. Now, that didn't actually get me from 1 to 4, did it? But it almost got me there. What I needed was one more statement because I wanted to now be able to get all the way to angle 4. So I had to get to angle 3 to get to angle 4. Do you see that? So now I can say, if I can see on line 3 that angle 1 is congruent to angle 3, and from line 2, angle 3 is congruent to angle 4, then I can use the same property to state that angle 1 must be congruent to angle 4. And that's the transitive property again.